When we had variables on both sides of equations back in chapter 1, we did it by solving them algebraically, by doing it all with variables and inverses and all that kind of things. What I want to show you in this lesson is how to solve the variables on both sides kind of equation by using graphs. So let's check out example 1. What they're telling you in the little step 1, step 2 thing is that first you want to take each of the parts and just kind of split it up and make it say y equals, and then you can graph them. So the first equation that I'll write is y equals x minus 2, and so the slope is 1, and the intercept is 0, negative 2. The other equation that I want to look at is y equals negative 1/2 x plus 1, and the slope is negative 1/2, and the intercept is 0, 1. So I'm going to graph these on graph paper, so let me make my grid. And I'm going to plot them one at a time. So first thing I'll plot is the first line. My intercept is at negative 2. And my slope is up 1, 1 to the right. The more points you have, the more accurate your line is. And connect them. And label the line. Now I'll graph the other line. The intercept is 0, 1. And the slope is down 1, 2 to the right. And I'll also go up 1, 2 to the left. That will give me a few more points, and I can get a more accurate line. So you can obviously see where they're intersecting. It's right here at the point 2, 0. But if you look at the initial question, there was just an x. We created the y value when we separated it. So this 0 doesn't really exist. It's the 2 that's the solution. So the official solution to this is x equals 2, not 2, 0. We have to check it by just plugging in 2 into the original equation and making sure that it works. So let me plug in. 2 minus 2 is 0. That's negative 1. And negative 1 plus 1 is 0. So it does check. Let's look at a separate example. So you have these two plants, and they're growing at different speeds, and it tells you that plant A grows at 0.6 inches per month. And this one grows double that, twice as fast, which would then be 0.12. No, that's not true. It's 1.2. That's what 0.6 doubled is. So it's growing at 1.2 inches per month. Whew. And so we have to use the model to write the equation. So they've given us the setup, and we just have to plug in the values. The growth rate of plant A, we'll do that one first, is 0.6 times x, because they want to know how many months it's going to take in letter B, plus its original height, which is 12. We want to know when that equals, when its value is the same as the other plant's. Growth rate times x plus its original height. So let's get them both in slope-intercept form. I'm going to separate them, and this one will say, random dot there, y equals 0.6x plus 12, and this will say y equals 1.2x plus 9. So what I want you to read down here with me is that once we have the equations written in slope-intercept form, we can use a graphing calculator to solve. So what I want you to do is have these two equations written down, and then I'll show you next time I see you in class how to put these in the calculator and find their intersection. There's a really cool feature that we can use. So if you have any questions, write them down, and I'll see you then.